okay, center cubic. When you draw the first Brillouin, you get something like this. Okay, that's the reason why I told you that I won't ask you to draw the first Brillouin on 3D, because it is almost impossible. Okay, so for BCC, the first Brillouin look like this. For FGC, the first Brillouin look like this. Second Brillouin for the BCC. Second Brillouin for the FGC. Third Brillouin for the BCC. Third Brillouin for the FCC. So now you understand why just now I say that I won't ask you to draw the 3D, because it is impossible. Okay. And remember just now I told you that for the body center cubic, the real lattice body center cubic, but when I convert it to the reciprocal lattice, it becomes face center cubic. Why? Okay, I'm going to prove it here. Now, we have one FCC cubic, FCC lattice, real lattice, FCC, and then I want to find the reciprocal lattice for this FCC. So based on this table, we know that if the real lattice is FCC, then the shape of the reciprocal lattice will be BCC. But why and how? So we're going to prove that FCC, okay, because just now I told you that I will try to solve the reciprocal lattice for the FCC, right? So eventually you will get BCC. Why? Okay, here you can see. So you want to determine the reciprocal lattice of FCC. So now first you need to select the coordinate system with unit vector I, J, and K. Then you need to position the coordinate axis so that in this system, one of the corner of the FCC unit cell will be at 0, 0, 0, and the edge starting there lie in the positive I, J, and K direction. So now you need to select three A1, A2, A3 vector to point to the center point lying on the 3 coordinate plane. So with this notation, you have A1 equal to A over 2I plus K, A2 equal to A over 2I plus J, and A3 equal to A over 2J plus K. Remember, in the first or second chapter, I can't remember, but in the early chapter, I teach you how to find the primitive cell for BCC and FCC, right? So for FCC, the primitive unit cell vector is A1 equal to A over 2I plus K, A2 equal to A over 2I plus J, and A3 equal to A over 2J plus K. A1, half I, half K. A2, half I, half J. So A half I plus half J times A lah. So A3, half J, half K, right? If you already forget how to get this unit vector for the primitive cell, then you can refer back to the first chapter or second chapter. Okay, I have explained during that time. So now, okay, is the formula for the 3 reciprocal vector B1, B2, B3. I think I want to take out the in. Delete the in. Okay, do you still remember this equation? B1 in here, it represents the reciprocal, or if you like, you can put it at A, B, C, or you can put it at A star, B star, C star. They are same, okay? So if you still remember, in last chapter, we have studied that A equal to 2 pi, the real A2 plus cross product with A3 over A1 times A2 cross product with A3. Exactly the same. Okay, so this is reciprocal A, reciprocal B, reciprocal C, real B, real C, real A, real B, real C. Okay, remember that, this equation. So now, you want to solve it. So we have the real A, real B, real C. Then we want to find reciprocal A, reciprocal B, reciprocal C. So we just substitute the real A into here, real B, this one, into this one and this one, and real C into this one and this one. Then you solve it. Then you will get B1, the reciprocal lattice. Same thing apply to the reciprocal lattice B. This is reciprocal A, reciprocal B, reciprocal C. So for reciprocal B, you substitute A3 into here and here, then A1 into here and here, then A2 into here. Okay, same thing apply to the B3 or reciprocal C lah. You just substitute here. Then now we know that A1 dot product with A2 cross product with A3 is the denominator, and it's also the volume. Okay, it's also the volume of the primitive cell. So A1 equal to A over 2I plus K, right? A1 equal to A over 2I plus K. I substitute here. A2 equal to A over 2I plus J. A over 2I plus J. I substitute there also. Then A3, A over 2J plus K. I substitute there. Okay. Then next, I solve these three term. Okay. So I got A over 2 times A over 2 times A over 2, you get A power of 3 over 8 lah. Then I dot I plus K, then this one is cross, right? Cross product. So this cross product, so maybe you just solve this one first. So I cross product with J, I cross product with K, J cross product with J, J dot product with K. Okay? Then only you expand this one and this one. So I times I cross product with J, I times I cross product with K, and so on and so on. Then you expand it. Then after you solve it, you get A power of 3 over 8 times I, J cross product with K, plus K, I cross product with J. Why? Because this one becomes 0, 0, 0, 0. Okay? Why is 0? This is a knowledge that you should get from vector course. You have gone through the vector analysis, right? Yeah, refer back. Okay, so you get this one. So you got the volume equal to this one. Then now we're going to use the fact that I, J, K are perpendicular to each other. So further we know that I cross product with J, you get K. J cross product with K, you got I.